You're supposed to do all these. I didn't provide answers for the programming questions here for a reason. I found out that too many students are just reading the question and answer, thinking that they can learn this by doing that. I mean, you learn your history material that way, but not computer science. You really have to get it out of your brain. Only when you do it, you really understand. By reading someone else's solution, you're not really learning. You're understanding that program, but you're not really understanding the technique and how to use it in another program. So really have to try and do it yourself, by yourself. That's when you really have learned it. And after you try it, if somebody explains, then you do get some of that. You do learn from that. But if you just read the question and answer, no, it's not going to do anything. And so that's why I didn't provide the answers there. So I'm going to go over the 38 first, and then after that, I'll take questions from you from any part of this. 38 is to have user ID numbers stored in one array and GPA stored in another array. Two arrays have to be used. Okay, and that's the main program. We'll use two arrays, int ID, and the size is maximum is 1000, it says. We don't know the actual size of the class. And I need subscript variable and then float array for the GPA. And again, that will be also 1000 maximum. We'll come back and add variables as we need. And then we need to get the actual data stored in these two arrays. And we don't know how many data we are getting. And so we have to use sentinel control loop. So I'm going to write, I'm going to ask for the first data at first. So enter ID and GPA for one student, that is. I has to start at 0, and whatever he enters, whatever the user enters is going to go into ID I. I is 0 right now, and he or she is going to enter two things, ID and the GPA. So I'm reading both. ID number goes into ID 0, GPA goes into GPA 0. So this is what we call parallel array. We are making two arrays. In the first one, we are putting all the IDs, and in the second array, we are putting all the GPAs. So the first student ID is here, and the first student's GPA is here. So 10th student's ID corresponds to 10th student GPA in the array. That's called the parallel array situation. We are making that parallel array. And while this is a sentinel control loop, so I got the first data before the loop begins. And while IDI is not equal to -1, I need to increment the I and get the next one. All we're doing in this loop is getting all the data going to the array. Enter GPA and ID, CN, same statement as before, IDI and GPAI. I'm getting two data, but loop is controlled by only one of them. We can do that. We don't have to use both. So when the user enters the ID and the GPA for many students, and when he's finished entering, he'll be entering a -1 to go here and a -1 to go here. He or she has to enter two -1s. But if IDI is -1, loop ends, and after that, the loop is finished, getting all the data into the array. We are storing -1s in the last elements of the array, -1, but we are not going to be processing them because our loop makes sure, I explained in the last class using example, when this loop ends, the value of I has the correct count of actual data. So I'm going to copy that into the variable count equal to I, because when this loop ends, I is equal to the actual count of data. I copy that into count to to make sure that count is done. And also a reader can understand this easily as the I being equal to count when the loop finishes. Now what I need to do is, according to the problem, you need to get a search ID from the user and search the ID. So cout, enter search ID, and cin SID to mean search ID. And then I'm going to have to search the function. Now, function search I wrote earlier. So we don't, according to the problem, you don't need to write the search function, but call the search function. So I'm going to call the search function and pass this array ID. I only need to pass the array ID. I'm going to search only the ID array. And the size of it is same as count. Count is the size. And search ID has to be passed, SID. And the function will search for this search ID within this array. And it will, if it finds it, it'll return the location of it. If it doesn't find it, it'll return -1. Whatever it returns, I'm going to copy into an M. It's a good idea to copy the returned value and then work with that. That way you don't have to call the function over and over. Now, if M is -1, we know that item is not there. So cout not found. And you return 0 to terminate the program. Because if the item is not there, there's nothing we can do. Else, item is found. Now, do I have to write else? Not really, because if M is -1, it'll write this message and it'll terminate the program. So therefore, it will execute the next statement I write only if M is not -1. So I don't have to really write else. But if I write else, that's not wrong. So else, M has the location. So according to the problem, we need to print that student's grade, GPA. So what should I say? Cout what? If the student is found, I need to print that student's GPA. I don't need to print the ID. ID I already have. That's a search ID. So I asked the user to enter the search ID. So user entered the search ID. And that is the ID of the student I'm searching for. And I searched that ID and I found the location. M has the location. And if M is -1, I put the message. Otherwise, what do I say I need to write? Cout what?
Can you do GPA M?
GPA M, exactly. Yeah, that's the one. Because if 10th element of the GPA ID array has the ID, then the same 10th element of the GPA array has that student's GPA. So GPA M is what I need to print. And that's all we need to do there in the main. So that's the main. Function search we already wrote. So that tells you everything. Okay, now any other question from this practice test?
Can we go over number 2?
Number 2. M equal to 3, N equal to 5. So pow Mn would be 3 to the power 5. 3 to the power 5 is what? 81 to 243. And 243 is multiplied by N, which is 5. So what is 243 times 5? That's what you're going to print. 243 times 5.
1,215.
Right, 1,215.
Okay, your answer was 486, so I just wanted to check that I didn't miss something.
Okay. So let me see number 2. Yep, I have a wrong answer. I don't know. Sometimes, I do that. I'm absent-minded nowadays. I change the problem and forget to change the answer. That should be what happened. So that's why we're having this discussion, to make sure everything is okay. So I have wrong answer there, everybody. The correct answer is 1215, 1215. Okay, I think I should go over 36, which is a typical example of RAND function that you run into. So let's go over that. I hope you tried to write these. If you tried, then you learn better when I go over it. If you just read the problem and watch me do it, you don't get much out of it. All right, so a gambling game involves paying a bet amount to get a chance to roll a wheel that has numbers 1 through 50. And so you roll the wheel and you will get one number in the range 1 to 50. And if that outcome is smaller than the bet amount, and also outcome has to be odd number, only then you win $10. And if you don't win, you lose your bet amount. So you have to calculate the net winning of playing this game 200 times. You have to play the game 200 times and write the net winning. All right. So how do you, one question a student in the other class asked me was, how do you account for the loss of the bet when you're calculating the win amount? Well, you just have one variable win to accumulate all the winning. And whenever you lose, you take out the lost amount from the winning. That's how you take care of that. So if you never won, then the winning number will be a negative number. Getting a winning number negative means you lost so much. You only need one variable to keep track of the winning. All right, so it's a main program. And you're going to play the game. So float type bet amount has to be received from the user, and win amount is going to be float, and I will start it at 0. I'll add the new numbers to current value of win, and in types variable I for control of the loop. My loop has to go 200 times. We'll come back and add more variables as needed. Basically, I need to start my loop because I'm going to have to say repeat the game 200 times. So I need to write that loop that repeats 200 times for I going from 1 to I less than 200. So this will make it less than or equal to. Because I started at 1, so it should go up to 200. I is not a subscript, so it can start at 1. I plus plus. This means repeat the following 200 times. And what are we repeating? Playing the game. Playing the game means getting the bet amount from the user. I had to get the bet amount first. See out, enter, bet. Each time the user plays the game, he has to enter the bet amount. So I need to read that into bet. And then I need to roll the wheel. So rolling the wheel is equivalent to using the rand function to generate a random number. So I'm going to copy the result in M. I'll declare the M up here. Okay, can somebody tell me how to write the statement to roll the wheel?
Rand mod 15 plus 1.
Right, on modulo 15 plus 1. Because we are going from 1 to 15. So if you do run modulus 15, they'll go 0 to 14. When you add 1, the whole numbers shift from 0 to 14 to 1 to 15. So that will give you a random number in the range 1 to 15. That's same as rolling the wheel. Now, if that M, the M has to meet certain conditions to make him a winner. M has to be an odd number and it has to be less than bet. So if M is less than bet and M modulus 2 is equal to 1, then it is odd and less than bet. If both happen, then he's going to win $10. How do I account for that? Anybody? What do I do if he wins?
I had net plus equals 10, but I don't know, you don't have that variable, so I'm not sure.
I have win amount for, so win.
Oh, okay.
Yeah, what you're using net is my win. Win equal to win plus 10. Add $10 to the win. And according to the problem, if you win, then you don't lose your bet. So that means I don't have to take out anything from the win amount. Else, if this is not true, now he has already bet an amount and he has rolled the wheel. So this condition has to be true for him to win the $10. If that's not true, he's going to lose the bet amount. So win equal to what? Anybody?
Win minus bet.
Win minus bet. And now we can close the loop. And that loop will play the game 200 times and it will accumulate the win amount. Every time the user wins, $10 will be added. Every time he loses, bet amount will be deducted. So the final win amount is what we need. When the loop ends, I can print C out U1 amount equal to the win. And that's it. There was a problem similar to this in one of the homework. That was not homework 21 or 20 earlier one. Anyway, but this tells you exactly how to write these game programs. Anything else from this practice test?
Can we go over 17?
17. Yeah, 17, sorry about that. It turned out that I have an error there. First of all, this for loop here is wrong because it has only two things. You're supposed to have three things. So I basically need a semicolon behind this. If I have a semicolon behind that, then the for loop will be correct. And still my answer is incorrect. Apparently I had a different program in mind when I made the answer. I don't remember what happened. But anyway, the program basically says for I going from 0 to I less than, I should be controlled by n, I say I less than n, for all those i's, bi modulus d must be equal to 0 for the loop to continue. So that means when I is 0, for example, you're looking at 12. And 12 modulus 5, d is 5. 12 modulus 5 is not 0. So since 12 modulus 5 is not 0, the loop is not going to even get started. So nothing will be returned. So that's why the program, the whole thing is error. So your answer would be error. Nothing will be returned. Okay.
Okay, thank you.
Mhm. Anything else?
Just a quick question for number 3. Your answer was 0.7160, but when I put it in the calculator, there was a bunch of decimals. If we put all of the decimals in the calculator and like don't round it, is that still right?
Okay, square root of 6.25 should be, let me find that, 6.25. 0.7905. Yeah, you can just write 2 decimal digits. That'll be good enough.
Okay.
Round it to the nearest 2 decimal digits. Okay, so 0.79. And what do I have? I don't have 0.79.
No, you had 7160, which I think that was right though, but I just had extra
All right.
numbers.
So yeah, you can, when I, yeah, this is all going to be on Blackboard. So I will allow 2 digits or 4 digits rounded number will be considered to be correct. I'll allow both of them to be correct. So you need to round it to 2 digits or 4 digits, depending on the question. But I will try to make sure to tell you in the question itself to round to how many digits.
Okay, thank you.
Mhm. Okay. Only 2 students are asking questions. No one else has any question?
Can we do 21, Professor?
21, okay. Write a program that adds up the series 1 squared, 5 squared, all the way to 57 squared. And it says, do not use library function. Now, remember, there are library functions that we haven't discussed. For example, when I wrote in the homework problem that says convert your letters to uppercase letters, one of the students wrote library function to upper. There's a function called to upper that'll convert lowercase alphabet to uppercase alphabet. So he was right about the function, but that's not allowed here. You have the problem actually wants you to write your own function, not to use library function. So in the test also, even if I don't say do not use library function, only the library function we discussed you can use. You cannot use any other library function. Any question I asked that doesn't involve one of the library function we discussed is asking for you to write that function. So anyway, this particular one is going to be just adding up a series. So I'm going over 21, which says add up this series. It's going to be a main program, and our numbers start at 1. Even though we are adding the squares, the base number is what you're going to use to control. That number is going from 1 to 5 to 9. So there's a pattern on that number. We don't have a pattern on the squares. So therefore, int n equal to 1, that's the beginning number. And I need a variable sum to hold the sum. You need to put 0 there. And then I can use a for loop since I know exactly where to end. If you use while loop, that'll be correct too. Int n equal to 1 to n less than or equal to 57. It goes up to 57 and n increases by 1 each time. No, sorry. I'll put a semicolon here and leave that blank. It's not going to go up by 1. I'll leave that blank. Okay. You can leave any part of the for loop blank, but you need that semicolon there. For all these different n's, I need to take n squared. So that'll be n times n added to sum, current value of sum. And that's why there must be a current value. You must put a 0 in it, otherwise this statement will not work, because it says add n times n to sum and then put it back in sum. That's how you accumulate. Sum equal to sum plus n times n. That's the only way to accumulate. And after adding n times n to sum, the n has to change to go to the next one inside the loop. And so bracket, I need to change the n. how do I change? N should go up by what? Anybody?
4.
4. So n equal to n plus 4, right? And close. And that will add up all of those numbers. And when the loop ends, just see out the sum. You understand it, or should I go over step by step?
I got it now. Thank you.
Okay. Anything else?
If we want the answers to the other questions, do we just email you?
Yeah, you can do that. The reason why I didn't write that was I noticed that some students are getting the wrong idea, that they think they just have to read the question and answer. Well, that works for biology class and history class and all that, but not here. It's just like advanced math. Basically you need to learn the idea, learn the skill by doing it and not by reading. And that's why I didn't present it. So yeah, if you are struggling with it, if you have no idea, then yes, you can ask for it by an email, or you can ask for a meeting. Alexander, you have done that before. You asked for a meeting, and I gave you the meeting. So feel free to do that. This weekend I'll be tied up with some other things, but I can offer you a meeting before that.
Okay, thank you.
You're welcome.
Professor, can we do 26?
26, all right. Okay, 26A is write a program that repeatedly obtains a value of y until 0 is entered. And for each value, it'll compute the sum of this. So it'll compute the sum of this for different values of y. And so there will be 2 loops needed. Computing this is a loop, clearly. You need a loop to add up all these. And then doing it for different y's will be another loop. Okay, so main program begins. I declare float y, and I also need the sum. Sum starts at 0, and that's all I need. And it says do not use any library function for a reason. Even though there are powers of y here, you don't need the power function to compute them. You can generate all those powers by following the correct steps. I'm going to show you how. So I need to ask for the data y first. See out, enter a value of y, and see in y. After that, this loop, first loop, is going to control by this sentinel while y is not equal to 0. 0 will be the sentinel. While y is not sentinel, I need to use that y to add up the series. So I need to set the sum to 0 here. So I could have that sum equal to 0 is okay, but I need to do it here again. I'll explain why. Set the sum to 0 and then start adding up the series. The y is known now. A student just came in. She must have been thrown out by the internet connection. Anyway, sum equal to 0, and to add up that series, I need to I need to have numerator and denominator because they are both changing. So numerator equal to 1, denominator equal to 1 for the first term, numerator equal to y. So I'm going to say numerator, I have to start the numerator to some variable here. So I will say numerator equal to 1 here and denominator equal to 1. And then I would say numerator equal to, yeah, for the first term is going to be 1 over 1, or wait, I'm trying to find the right place. Yeah, I think I should set the numerator to y here, right here, numerator equal to y. Okay, because only after I get the y from the user, I can do this. So numerator equal to y. And now I can say sum equal to, I need a loop. So inside the loop, sum equal to sum plus numerator divided by denominator. Denominator is 1 right now, numerator is y right now, so I'm adding y over 1. After adding that, I need to change the numerator and denominator to go to the next. So I need to prepare for the next term. To get the next term, I just need to change the numerator by doing numerator equal to numerator times y. Can you see that? First term has a y in the numerator, next one has y squared, and next one has y cubed. So that means by multiplying each numerator by a y, I get the next one. And similarly, a denominator goes up by 1. So denominator just simply increases. And that's all I need to do. Add the current numerator over denominator to the sum, and then change numerator to go to the next numerator, change denominator for the next denominator, and close the inner loop. The inner loop begins here, and it will say while denominator less than or equal to 20. See, the denominator becomes 20 means we are done. So I can use denominator to control. While denominator less than or equal to 20, keep doing this. This whole thing has to be inside the inner loop. This while loop here is adding all the terms of the series. It's adding numerator over denominator to the current value of sum. Initially it's 0. And then num changes to next numerator and denominator changes to the next denominator. With that, as long we go back and check this condition, as long as denominator is less than 20, we will add the new numerator divided by denominator to the sum and change the numerator and denominator. Go back and check the denominator. As long as the denominator is less than or equal to 20, we keep adding. So this will finish writing the loop, computing the sum for each y. So see out the y and space and then O tab and write the sum. And after you write the sum, ENDL, on one line we write the current y and the current sum. And then I have to get the next y. So see out, enter value of y and see in y, and there you close this loop so that with the new y, after getting the new y, I go up to the top of this outer loop. As long as y is not sentinel, I reset the sum to 0. See, that's why I did that sum equal to 0 here. I'm now adding up a new series. So my sum has to start at 0 now. And then, oops, I have another thing I didn't realize. The numerator and denominator also have to be reset for each series. So in addition to sum going 0, the numerator and denominator have to be also changed. So the numerator has to be equal to y, and denominator has to start at 1 again, and also sum has to set to 0. All that has to be done. So the denominator equal to 1 up here, we don't need. It's going to be set to 1 here. And the numerator equal to y also we don't need here. I'm doing it here. I had to do it inside. Because after writing the sum for the current series, I get the new y. After I get the new y, when I go to the top of the loop, if the y is not sentinel, I have to start over for the new series. So numerator has to reset to y, denominator has to reset to 1, and sum has to reset to 0. Then you add up in the loop. You add up the new series. and you write the answer for the new series, get the next y, and go on. Only when the y is 0, then this outer loop terminates. And so that's all we need. All right, so we are out of time now.